Okay, hope everybody's doing okay today. This is a quick note on some of the radical lessons that we've been doing. Um, this is called the factor chart. I did give it out to you, I think it was like a week or so before we closed schools back in March, but if you don't have it, you can print one out or you can just use the PDF copy and keep a copy on your phone or something to refer to later. But factor chart is chart of numbers. So at the top there, that line 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. You're following numbers consecutively in order. And below that are the factors of those numbers. What are factors? Factors are um, two numbers that will multiply to make that number. So if you notice on the number 1, right, it only has 1 times 1. On 2, it only has 1 times 2. On 3, it only has 1 times 3. On 4, though, that has 1 times 4 and 2 times 2. So it has two different factor groups that make it. Okay. And so if you say, what are the factors of 4? Well, the factors of 4 would be 1, 2, and 4. We wouldn't repeat a factor there, but I am highlighting those special factors, the 2 times 2 and that 4 that belongs to it. What would the factors of 8 be? The factors of 8 would be 1, 2, 4, and 8. Could you have written 1, 8, 2, 4? Yeah, you could have written them in any order. I'm just writing from least to greatest, though. Okay, so those are what factors are. The reason why, in particular, 1, 4, 9, 16, 25 were all highlighted is because of those particular factor pairs that make those numbers there. What is it about those factor pairs, right, are exactly the same set of factor pairs. And so when we look at those numbers like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, those factors, those numbers have factors that are two factors that are exactly the same. 12 times 12, 11 times 11, 10 times 10, right? 9 times 9, 8 times 8. So that's why those are called, those particular numbers are the perfect squares. Because you can square a number to equal that perfect square number. 2 squared is going to equal 4. 3 squared is going to equal 9. And 25, right, is 5 times 5, 5 squared. All right. So the reason why I'm showing you all this is because when we have any number, we can use these factor charts to help us simplify those radicals. What do I mean? I mean, like, okay, so say if you were looking at taking the square root of 108, right? You could do it two ways. One way is to take 108 and just start breaking it down into its factors. So say I'm thinking about what is going to go into 108. Well, if it's an even number in the single digit place, right there, so the 8 is even, right? It can always be divided by 2. So that would be 2 times, what would it be? I think 54. All right. I can't factor 2 to any other factors other than 1 times 2. Oh, just a quick note, going back up to our numbers there, right? So number 1, number 2, number 3, number 5, number 7, 11, 13, 17, 29, 19, 23. Those are all what? Prime numbers, right? Okay, so those are prime numbers that we only have factors of 1 in themselves. Okay, so if I'm looking at a number like 108, I've got my 54 there now. I'm going to stop with 2 because 2 is a prime. And I'm going to factor again, I'm going to factor 2 out and go, okay, 2 times what makes 54? 2 times 27. And then 2 is another prime. I can't factor 27 any further, except for maybe 3 times 9. 3 is a prime number. 9 is going to be 3 times 3. This is called factoring to a series of primes. So what is that? That's a 2, 2, 3, 3, 3. And then I would list my product of factors under the radical, and it would be 2 times 2 times 3 times 3 times 3. All right. And so when I have all my factors under the radical, there's this story about factors and radicals in a radical prison. How do these radical prisoners, the numbers inside the radical sign, break out of the prison? Well, they can only break out with twins. So they need a twin group to approach the gate and break out of this prison, where one of the twins makes it over the fence and the other twin is left behind, and a guard is going to take care of them and eliminate them. So the 2 makes it outside. Then we look at the 3s, pair of 3s, right? One twin makes it out of the fence, one of them doesn't. Who is left behind that did not have a twin? Well, that's going to be the 3. So the radical 3 is on the outside. But we're not going to leave that 2 times 3 like that. We're going to change that to what? 6 radical 3. And that is an equivalent way, and it's the exact square root of the number square root of 108. This is more accurate than what your calculator is going to tell you, because your calculator is going to tell you a whole bunch of decimals, and all those decimals are going to be an approximation. But 6 radical 3 is exact. You're especially going to have to know that kind of simplifying when you get into geometry next year. All right. So that's one way you can do it, factor primes. But the other way is to use your factor list. So I'm going to do 108 and use the factor list. Right? I'm going to look for 108 on that factor list. Come on now. There we go. All right. So there's 108, right? And it's got several factors there. All right. So it's got 1 times 108. That's really not going to help me, though. I don't want to leave it square root of 108, square root of 108. All right. Then I've got 3 and 36, 4 and 27, 6 and 18, 9 and 12. But what I want to look for, though, specifically, were those perfect squares. So if I'm looking at those perfect squares, 9's a perfect square, 4 is a perfect square, and 36 is a perfect square. So I got 3 options that I can use. I can use 3 times 36, I can use 4 times 27, or I can use 9 times 12. So the part that you got to look at here now is which grouping of them has the biggest perfect square? Who's the biggest, 36, 4, or 9? Well, I'm hoping you're saying to me 3 times 36 is. Why? Because 36, right, is a perfect square where its 2 factors are what? 6 times 6. Okay. So when I'm thinking about this 108 as a square root, it's like the square root of 3 times the square root of 36. When we have radicals that are the same index number, in this case, when there's no number there, they're automatically a 2. We can take those 2 numbers and multiply them together under the same radical. And we separate them like that mentally. So we can say, okay, what's the square root of 36? That's my 6 times 6. So the 1/6 comes out, right, out of the radical prison. The other 6 gets eliminated. And then who did not have a twin to break out with? That square root of 3. So that's why we would have 6 radical 3 there, right? I don't care which method you use, but try to use a method, right? Don't just try to plug it in on your calculator because you can't just plug these in. You'll get decimals, and decimals are going to be messy. And then especially with the next lesson that you look at with the variables and factoring variables, same deal. All right, so that's a factor list. I hope you use one for simplifying these radicals, especially on your review packet that I'll be giving you this weekend. Thank you.